Greetings students, Mr. Pence here, and I'd like to give you a brief introduction to pedigrees. So if you can turn to this page in your packet, you'll see the same diagram that I'm looking at. Things to notice about pedigrees: they're family trees, right? They're showing the inheritance of genetic trait over many generations. And so things you need to know about them is first the shapes, right? It's important to note that circles represent females in a pedigree and squares represent males, and you can see that in the diagram here. So you can see also that we indicate relationships, right? So first relationship to notice is that marriages are indicated with a horizontal line connecting a square and a circle. So those two individuals in generation 1 are married, and then other lines to note are vertical lines, right? Individual U, individual V, individual W, and this unlabeled individual. Those are all the children, right? And so anytime you see a line going into the top of a shape, it indicates that that person is a child of the generation before them. So what I want you to do now is I want you to stop, pause the video really quickly, and quickly tell me, how many kids do the parents in generation 1, how many kids do they have? Now, if you pause the video and thought about that for a second, the correct answer there is 4. Individual U, individual V, individual W, and this unlabeled individual over here on the right are all the children of, they trace back to the marriage line between those individuals. Notice that this male here, this female, those are not children, right? If you think about it, those are going to be individuals that marry the children. So those would be the in-laws, right? The son-in-law, the daughter-in-law of those original parents, okay? So we can see here then also other things about the shapes. Now, regarding the color of the shape, when we're tracking a genetic trait, a open shape, whether it be a circle or a square, indicates that that individual is normal. From what we learned in class, these individuals, in a lot of cases, in most cases, would be homozygous dominant for whatever the trait is. When individuals have a disease, their shape would be completely filled in. And in this case, since it is a homozygous recessive condition that causes the disease, a circle or square that's entirely filled in would mean that person is afflicted with the disease. Lastly, carriers are individuals that are heterozygous. That is, they have one dominant allele, but they are carriers of that recessive allele. So that means they don't have the disease, but they could potentially pass on the disease to other individuals. Okay, so we see 3 generations here. Individual U, she marries, she grows up, she gets married, and she has 3 children. And individual W, he marries, and he has 2 daughters. And the last child gets married, and she has 3 sons. Okay. Other things to notice about pedigrees is age is somewhat apparent, right? First of all, the generations, right? You can infer that the individuals in generation 1 are older than individuals in generation 2, and those are older than generation 3, and so on. But within a generation, you can also notice age there. The eldest child is shown at the left, right? So individual U in the second generation is the firstborn female child of those 2 parents in the in the first generation. Individual V is the secondborn, individual W is the thirdborn, and that unlabeled child on the right is the youngest child. Okay? Second question here. Pause the video for a second. I want you to tell me, what is the relationship between individual X and individual Y? Okay, if you paused and thought about that for a second, the correct answer there is individual X and individual Y are cousins, right? Because they are related to their parents, right? Daughter U and son W, they're brother and sister, right? And so their kids would be cousins of each other. Okay, now last thing we want you to do is we want you to apply this. So we're going to ask you to pause. You're going to probably need to pause the video a longer time here. If you turn your packets to this page, let's make it a little bit smaller. You can see you have the case studies for drawing a pedigree, and you have to be able to do this. So if you read through case study 1, I want you to pause the video now, and I want you to try and draw out this pedigree here. It might take you 5-10 minutes. When you're done, you can hit play, and we'll see how you did. All right, welcome back. I hope you had success in doing that. So let's check your work. I'm going to open up another page here, and we're going to quickly try and draw that out. All right, so you've got 3 generations here. We've got the parents. We've got the father does not have cystic fibrosis, so his shape is empty, and the mother is a carrier, so we would half fill in her shape. They have 3 children, right? So I'm going to drop a line from their marriage line, and I'm going to make it nice and wide so that we have room for everything. And then I'm going to go through each children. So we have the first child. The first child is a male who is a carrier for cystic fibrosis. He is married to a female who is also a carrier for cystic fibrosis. They have 2 children. The firstborn is a male, and he has the disease, so his shape would be completely filled in. And the secondborn is a daughter, and she is a carrier, so her shape would be half filled in. Their second child, it said, the second child is a male, and he's normal, right? So his shape would remain empty. He's married to a female who is also normal. Her shape would be empty. They have 1 child, a female, and they have a daughter. And that daughter is not a carrier of cystic fibrosis, so she's normal. Her shape would be open as well. The third child is a male, and he is a carrier, so I would fill in half of his shape. And he's married to a female who is not a carrier. She's normal, so her shape remains open. They have 3 kids. And it says that the firstborn and the thirdborn, the oldest and the youngest, are both normal. So the oldest is a male, he's normal, shape is empty. The youngest is a daughter, she's a circle, her shape is open. The middle child is a carrier for cystic fibrosis. So when I see that word carrier, I'm thinking heterozygous, and her shape would be half filled in. So hopefully this helps you understand pedigrees a little bit. And if you still are having trouble, please come see me in class.